Hi, let's get started. This lab is on configuring Cisco IOS for both a switch and a router. So this is the lab here that we're going to be using on the left here. You should have access to this document. And I'm going to move it out of the way in a moment here. But there's a script that I am going to be following and that you can follow too. And I'll talk about all of this stuff in the video. All right, the first thing that you'll be doing is downloading this packet tracer file right here. So that's here, download lab one, blah, 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 blah. And what we're going to be doing is I'm going to be introducing Cisco IOS by configuring the switch. Then we're going to configure a router. Then we're going to configure the PCs, do a little ping, a little telnet, and then verify reachability. All right, so before we get started on this, typically in, I was going to say the real world, but on real equipment, what you'd be doing is on most networking devices, they have some kind of console port. Cisco devices call it a console port. There's only one. And here's the console port here on this diagram here. And we use something called a rollover cable, a special rollover cable. For those in my classes, I'll be bringing this stuff in so you can physically see this stuff. We have the cable then attached to typically what is a serial port on a computer. Using a RJ45 connector to a DB9 or DB25 port. I'm sure you don't even know what serial ports are anymore. We don't see those very often anymore. So you can use USB, by the way. So, and I'll be showing that in the classroom. So this could be a USB connection here. Now, this switch or router is acting as a computer. We are acting as a dumb terminal. Back in the old days when Rick used to work on mini and mainframe computers and that, we used to have terminals connected to the computer. So to make your computer act like a dumb terminal, we typically use something like a terminal emulator. And we choose that we're connected to the serial port. So you'd actually on PuTTY or TerraTerm, choose serial. And then say which communications port you're connected to. The parameters that we're going to be using, because this is what the device, the switch or router is expecting, is this baud rate, number of data bits, number of stop bits, no parity, and really no flow control. All right. So those are the parameters. However, packet tracer, we don't need to deal with that. I'll show you in a moment. All we do is click on the device, command line interface, and it takes us to the device, connects us to the devices if we were connected to a console port. And this is the only way you can actually configure a device until you make it network accessible. We'll be doing that in a moment with our devices. But for at least initial configuration, this is how you have to do it. All right, the other thing I want to mention before we get into this is we're going to be doing a couple more things I want to mention. This here, we're going to be using some commands. So we'll have our prompt, and then we'll be given a command, followed by a space, followed by keyword or arguments. All right, so you'll be seeing that momentarily. And the last thing I want to mention before we get started is I mentioned that routers, switches, they're really computers, okay? So they do have a central processing unit, a CPU. They have RAM memory. All the configurations that we're going to be doing, so these commands that we're going to be entering, are actually entered into RAM memory in a file called, or data structure called a running config file. So we'll see that momentarily. When the router boots up, by the way, it gets its operating system from Flash, where the operating system called iOS, Internetwork Operating System, is actually stored. That's a big iOS as opposed to Apple's iOS. And like all computers, when it first boots up, it actually has some firmware, software and firmware, that is some boot instructions that boots the device up. I probably should have gone this way. Boots up using the firmware and ROM, then loads the operating system from flash. This iOS gets loaded from flash into RAM memory, just like your computer. The operating system gets copied into RAM memory. Now we'll be doing, like I said, all our configurations will be saved, not saved, but stored in the running config in RAM. We will want to permanently store that information eventually, once we think everything's working well, copying the running config into permanent memory called non-volatile RAM in a file called startup config. Don't worry about that right now. We will get there. All right, so I think I can move all of this out of the way. I am going to be following this script as we get started here. Okay, so here we have our packet tracer file. Now you see some addressing on the PCs, the router, and the server. This addressing has not been done yet. That's what we are going to do. Okay, we're going to start off with this switch here, and then configure this router. Then I'll talk about this switch at the end. And we'll also configure the addressing on these devices. And it is all in this little document, PDF, whatever you want to call it, whatever you use, that you can follow along with in the script. So let me get started here by just clicking on the switch. Oh, I want to mention, see these green link lights? That means that they are enabled. It is connected. We have it has a signal, sees a signal, has connectivity. These are red. That's because these ports are shut down. Okay. All right. I'm just going to click on the switch. That's all I'm going to do. And if you're new to Packet Tracer, I'll mention in class some things that, or the TA will mention some things that we recommend you look at to get more familiar with Packet Tracer. But zooming in here, this is the physical layout. So we can see the switch right here. These are all these are fast Ethernet ports, 1 through 24, and these are 2 gigabit ports. If I, let's see, should be able to look at the, all right, let's see. I think we're good there. Okay, the console port. Oh yeah, let me show you the console port right there, which is actually on the back. Okay. Now our PCs, by the way, this PC is connected to this switch, this PC connected to this switch. It is connected, and if I just kind of wand over that, you can quickly see it comes up just briefly, maybe. Come on, get on the link there. FA01, see that? FA01, we click on over FA02. So this is, one PC is connected to this port, one PC connected to this port. All right, I have another Packet Tracer video exercise if you're new to Packet Tracer and want to see how all these physical connections work. But let's, you and I, get started. So what I'm going to do here is click on the CLI tab. Okay. And I don't know if you can see it here. It's already booted up on me, but the switch, excuse me, has booted up. This is loading the iOS in from flash into RAM. And at this point, we are booted up. Now, we don't have a prompt right now because Rick has to just hit enter. Ah, there's my prompt. Okay, so right now I am in what is called in user mode. Okay, user mode means that I can't make any changes to the switch. This isn't the mode we give all of our users. Okay. The help feature in iOS is just a question mark. It tells me what commands or what parameters after a command I can use. So we can see these are the commands here. For example, the show command, if I want to see what, if I just do show here, press enter, it tells me incomplete command. That means it's expecting something after this command. How about show question mark? What do you expect? Any one of these parameters, and perhaps there's more parameters or arguments after this. Now, when I see this little more here at the bottom here, it just means that there's more information. If I press the space bar, it will give me another screen's worth of information. If I hit the enter or return key, it'll give me the next line, or any other key will just halt the list output. I'll just hit a space bar. I think I only have one more after that. Yes, VTP anyway. All right, so notice it leaves me off where I was. What if I chose show MAC address table? You might remember that from previous classes. MAC dash address table. That's a hard one to write out, isn't it? Let me hit enter. There's nothing in the MAC address table right now. Now I can hit the up arrow key to bring back the history of the last 10 commands. I'm going to show you something though. I can also do this. I can do show MAC. Now, as long as what I've done here is unique in my choices here, I can hit the tab key to autocomplete. Now, this is not unique because I have MAC and MAC dash. Okay, so if I hit the tab key, it says it doesn't help me. But if I hit dash, it is unique and it will autocomplete. I'm going to hit tab here. Auto-completes the rest of the command. Now, do I have to type the entire command in? No, I can just type in enough that makes it unique, like that. Show MAC dash, and it knows, oh, you mean MAC address table. Yep. Okay, so we'll be using I'll be using the tab for autocomplete just so you can see the entire command and Rick doesn't make a bunch of typos. All right, this is user mode. Okay. Once again, this is just for viewing information. This is a mode we give our network operations staff where we want them to look at devices, but we don't want them to make any changes. If we want to make changes, we have to go into something called privileged exec mode. To do that, we type the command, and actually you can see it if I scroll up here. You'll even see it here. Maybe, it's not in there. Isn't that interesting? Made a liar out of me. Okay, enable. That's interesting. It's not in Packet Tracer. Packet Tracer is not complete Cisco iOS. It does a great job at the basics, but it's not the complete operating system. All right, back to this. You notice I typed enable. What happened? My prompt changed. What does that mean? I'm in a mode called privileged exec mode. This allows me to actually make changes. Okay, and you're going to see that we have more options in this mode. Look at all this. Okay, even if I do show command, I have options I didn't have before. Let me make this a little wider so we can. There we go. I have options we didn't even have before. For example, show running config. If you do the show space question mark command in user mode, you won't have this option. Okay, let me show you what this running config is. So I'm just going to do show run, and hit tab for the autocomplete so you can see the entire command there. I'm going to parameter. I'm going to hit enter. Whoa, what's all of this stuff? Look, there's even more. Let me just keep on hitting the space bar. What this is, back at the prompt. Let me go back up here. Okay, I'm actually going to scroll. Let me scroll this down here. So, yeah, no, I'll leave it like this. All right, show running config. This is the blank template of what the switch defaults to as far as parameters. Now, we haven't configured anything yet, but anything we configure will be added or updated to this data structure, this running config file. All right. So, for example, let's take a look at a few things. Now, this running config is in RAM memory. Yep. And we're going to make some changes, excuse me, some changes here in just a moment. Okay, so right now, excuse me, I am in privileged exec mode. If I want to get out of this mode and back to user mode, by the way, I type disable. Notice I'm back in user mode. If I try that show running config command from this mode, notice, doesn't recognize it. Nope, sorry, Rick. You have to be in privileged exec mode. All right. Now, we're going to see in a moment that we're going to want to protect going from a user to privileged mode. We're going to require a password, but we'll do that in a little later. Okay. All right. So just so we get a little practice at how we use the help command, let me show you something here. I'm going to show clock. What this does is it shows you the date and time that this device has for the date, and time. It defaults to March 1st, 1993, and whatever time that is. Okay, setting the correct time on devices, networking devices, is very important. Okay, because when we are troubleshooting a problem or looking at a security issue, typically we're going to be looking at various devices, and we want to know the exact timing of what happened where on what device, and that means all their times have to be correct and synchronized. Now, this is not how we would do it. We would actually use a protocol called network time protocol that all of our devices would sync their clock to, similar to what your computer does. But just to show you how to use Cisco iOS and the help feature, I'm going to use the clock command. So if I type clock and hit enter, it tells me, incomplete command, right? Clock, question mark. What do you want? Oh, you want the word set. Okay. Now, if I hit enter here, it's going to also tell me incomplete command. So I'm going to just assume it wants something more. Question mark. Oh, hours, minutes, seconds. So I don't know. I'm going to put 13:30. Okay. And I'm going to assume you want something more. Okay. If I hit enter, it'll tell me incomplete command. What do you want? I have two options here. I can give the day of the month or the month, because the way that we represent the date is different in different cultures. Sometimes we use the day, sometimes we use the month first. Okay, what am I going to do here is I will actually do the month. So let me go ahead and put April, and then I'm going to do question mark. And now it says, look, the only option you have now is the day. And I'm going to put a 4 here. Okay, now what do you want? Question mark. You've got it. Once the year, 2023. Okay, let me then space, question mark. Anything else? Okay, whenever we see CR, that means we're done, carriage return, or we have the option of being done. Sometimes it shows us carriage return here, and we have other options if we want more, but this is at minimum what it needs. So I'll hit enter. There we go. It liked it. Let me do show clock again. And we can see our new time and date settings. Okay, and that's really just to show you how to use the help feature. Okay, so most of the times when we are configuring something on a Cisco iOS device, router or switch, we have to be in a mode, after we go into privilege exec mode, a mode called global configuration mode. And we do that by typing configure terminal. Now you will notice that I'm still in privilege exec mode, but I have this. I have this prompt here. Okay, at this mode here, I actually have a whole bunch of different commands. Okay, the command that we're going to do first is I'm going to set the host name. You're going to see something here in a moment. I'm going to say host name. This is where I give a name to my device, like S1 for switch 1. In a production network, these would have more meaningful names, usually the type of device, location of the device, things like that. But we'll keep it simple. Notice when I did that, hostname S1, my prompt changed. Okay, a couple of other commands we want to do. Let's see here. Should I show you this? Yeah, I'll go ahead and show you. How do I get out of global configuration mode, by the way? The way I get out of global configuration mode is I just type exit, and that takes me back to this prompt here. Now notice I got some iOS message. I just hit enter, get a fresh prompt. Okay, if I type something like this, and Rick's going to have to pause the recording because, translating. It thinks I'm trying to give it a command or really trying to access another device, and it's looking for a DNS server. This will take a couple of minutes. So what I'm going to do is pause the recording here for a moment. Okay, that literally took about 2 minutes to do. Okay, I'm going to show you how to keep that from happening when you actually accidentally make a mistake. I'm going to go back into global configuration mode. Okay, and I'm just going to abbreviate that conf T. That's good enough. See? Just do conf and T. I'm going to back up here. Just okay, that takes me global configuration mode. This is one of the first commands I do. IP domain, no IP domain, lookup. Okay, that's going to keep that from happening. Let me do that now again. Okay, I do exit, hit enter, give me a fresh prompt, type something like that. Boom, no problem this time. Okay. All right, let's go back into global configuration mode. Okay. All right, this is where we're going to start most of our configurations is right here. We already did the no IP domain lookup. Keep that fat fingering from happening. The next thing I'm going to do is actually configure the console port. Okay, what I want to do is configure the console port. So I do line, con, or console. I can just do con if you want, 0. These are parameters that are specific to that console port that we have the rollover cable connected to. Okay, let me show you that port right there, that console port. Okay. All right. So what are we going to do on that port? Well, one of my favorite commands is logging and synchronous. And I'm showing you the complete commands, but you can actually just do the abbreviation that I'm doing. What happens is anytime we get a message from iOS, and if I'm in the middle of typing a command, it will give me a fresh prompt and leave me off where I start, put me back to where I was typing my commands. I'll show you what this means when it happens, but it makes life much easier for us. This next command I'm going to show you is one that should only be done in a non-production environment. I'm going to make sure that this device does not time out on me unless I exit. By default, if you have not, within, I believe, 5 minutes, done any input, entered any commands to the router or switch, it will log you out. That's what you want, okay? Because you don't want to accidentally be left logged into something and somebody has access. But in a lab network, we're fine. So this is a command to keep us from getting logged out. The next one I'm going to do is password Cisco login. What this does is when somebody wants to log in to the console port, connects to the console port, it's going to require a password. We don't want just anybody logging in to our devices, right? Or having access to our devices. We want to require a password. All right, now I'm going to type exit. By the way, notice when I did line console 0, it gave me a new prompt, config, global configuration, specifically line. And this line happens to be console 0. If I type exit, it pops me out of that level and takes me back to global configuration. Now, the next thing I'm going to do is something called a banner message of the day. Banner, whoops, if I can spell banner. MOTD, and then a delimiter. And I'll just use a $sign character here. So, and I hit enter, and I can enter any text I want. This is a banner that's going to show up when somebody tries to log in or access this device. I'll put some hashtags there. I'll say authorized access. Whoops, I can spell access only. Put some more hashtags. Okay, and I can be as creative as I want. Okay, and then when I'm all done, end with the character $sign, what I chose right here. Okay, and then a $sign, enter. Okay, let's test this. I'm going to test this banner, test our passwords. What I'm going to do is I'm going to exit out of this. Exit. That takes me back to my prompt. Notice I got the iOS message. Instead of having to hit enter, it gave me a new prompt. That's because the logging synchronous. All right. Now, if I type exit again, it's going to exit me out completely out of the device, including user mode. Let's do it. Okay. So this is what you'd see when you connect to the switch or a router. You hit enter. Hey, there's my banner message of the day, and it's asking me for a password. That password we did for line console 0, which is Cisco. You're not going to see it. I'm going to hit enter. We're logged in. Now, again, I am just at user mode. Okay, let's go into privileged exec mode. I'll just do ENA for enable. There we go. Now, I said all of these configuration commands are saved in the running config. Let's take a look. Show running config. Let's see what's changed. I'll just hit enter here a bunch of times and we'll scroll up. I think you saw a few things. Here we go. Our host name. It used to be just switch, been changed to S1. Here's that command we entered, no IP domain lookup. By the way, here's my iOS version that I'm running, 15. All my fast Ethernet ports, gigabit ports. There's my banner message of the day. Now, it will always show Control-C here, no matter what delimiter you used. Here's my line console 0. Password Cisco, login synchronous, exec timeout. Okay, so it's all being stored in the running config in RAM memory. If I was to reboot this device, okay, and that's turning it off, turning it back on, or using a command called reload, I would lose everything. So I want to save everything to my startup config file, which is in NVRAM. Remember, I talked about that earlier. Okay, if I take a look at what's in my startup config file, it will tell me, Rick, you don't have one right now. You haven't copied anything to this file. So what we are going to do is copy running from our running config file to our, and I could just do copy run space start, but I'm showing you the complete commands. Copy running config to startup config. Hit enter. It says, are you sure you want to send it there? Yes, I do. Hit enter. Done. Now, if I do the up arrow here, show startup config. Just like my running config. So if this device reboots, we're good to go. All right, one of the things we want to do is not allow any of our operators just to be able to access the privileged exec mode. So I'm going to go into global configuration mode, and I'm going to create a password to go from user mode to privileged exec mode. So that password, we do enable secret, and then we'll use class. By the way, the only 2 passwords we'll ever use in this class, or I believe, are Cisco and class. So that way, if you forget a password, you know what the password is. It's going to be Cisco or class. In the real world, no. Use whatever is the password policy, security policy for your organization in passwords. And there's other ways to actually manage this as well. All right, let's take a look at how this works. I'll do exit. I'm going to type disable. Disable takes me back to user prompt. Okay, I'll type enable. Now it's asking for a password. This password right here, class. There we go. All right. The next command we're going to do here is, and by the way, we'll see that all this is in the running config. Okay. All right, I'm going to go back into global configuration mode. And what I'm going to do next is configure an IP address on this switch so we can access it remotely using SSH or Telnet. Okay, now you don't need to do this on a switch unless you want to remotely manage it. And not all switches, depending on if they're manageable or not, will allow you to do this. Okay, but Cisco switches, of course, do. So we say interface, and we give a command called VLAN 1. We'll talk about VLANs later, but this will allow us to access this switch remotely. Now we're going to give an IP address. IP stands for IPv4. And I'm going to give it an address 192.168.1.5 space the subnet mask. Okay, there we go. And then I'm going to do no shutdown. So by default, your virtual and physical interfaces are in what's called shutdown mode. To reverse that, we do no shutdown. Okay. And we can actually get a message from iOS telling it now changed state to up. Okay. Now notice when I did this interface VLAN command, it took me into config IF prompt. I'm going to do exit here. And now I'm going to configure this switch to allow for telnet access. So what I do is line VTY, which stands for virtual terminal, 0, and I'm just going to do 0/4. 0 is my first virtual terminal port. There's usually up to 16 total, or 15 would be the next number. But we'll just do 4, which gives me 5 remote access terminals simultaneously. That means up to 5 people could telnet or SSH into this port simultaneously. You'd never have more. I've never done more than 2 or 3 people in an operational network where all of us are remotely accessing the same device at the same time. All right, so notice I get, again, config line, but I'm not in line console. I'm in virtual terminal 0/4. I'm going to give a password. Out of the way, Cisco. Again, the only passwords you use, Cisco in class, in this class. Okay. I'm also going to say login. And I'm also, that's login prompt, but I'm going to give this command here, transport input. And I'm going to do a question mark here so you can see it. So you have really 2 options, SSH or telnet, or you can say none, which don't allow remote access, or all, which means allow both. In a production network, you only want to use SSH, not telnet. Telnet sends the password in clear text and all the conversation between you and the switch in clear text. So typically we'd use SSH, but just to keep things simple, let's do telnet. All right. Now, notice I'm in this prompt, S1 config-line. If I do exit, like we did up here, it'll take me to global config. But I can actually use another command, end, to take me all the way back to what some people call the root prompt, all the way back there. Okay, so if I do show running config, okay, there's my enable secret. Now it shows it encrypted here. That's not strong encryption. It's just to keep somebody from looking over your shoulder. Okay, there's my banner message of the day. Here's my line VTY04. Notice that this password is not encrypted. We'll change that in a moment. And neither is our line console password encrypted. Okay, we'll want to change that in a moment. Encrypted in the running config. And that, again, not strong encryption, just keeps somebody from looking over your shoulder. Oh, I bypassed this. There's our interface VLAN 1 and our IP address. Okay. We'll make use of that a little later in this lab. All right. Now to encrypt these 2 passwords, I'm going to give a command. Let me go into global configuration mode, config T. And I'm going to give this command here, service space password. I'm going to show you the whole thing. Password encryption. Okay, let me hit enter here. All right. I'm going to hit exit. So I can do show running config again. And you'll notice that our 2 Cisco passwords are encrypted. Again, not strong encryption, not meant to be. Now this is looking good. I feel fairly comfortable with this. So I always do copy running config to startup config, so I don't lose anything. And what you should be doing in your lab is save your packet tracer file. Okay, so I'll come over here and I hit save right up there. Okay, I'm not going to do that here, or you could do file save as either. File save as, you know, let's save that. I'll put my name here at the end, so I don't overwrite the one I use for this lab. There we go, save. All right. In case anything happens. Okay, the next thing we're going to do, configure the router. And then we'll come back and do some other cool things. So let me close this. Now I'm going to click on the router. Now our router has 2 ports, gigabit 00 and gigabit 01. That's what the G stands for, gigabit Ethernet. If I zoom in, we can see those 2 ports. Oh, if I can see it. Your eyes are probably better than mine. There's the console port. I'm guessing, oh yeah. So anyway, I can't see it. Your eyes are probably better than mine. All right, so those are our 2 gigabit ports. Okay, I'm going to go to CLI here, and it's booted up. Okay, and by the way, if you ever get the message, let me see if I can get this to do it. Let me reload this. This is a way to do a reload. Now, it takes longer on real devices. I'm soft booting, in this case, the router. This is showing that it's there we go. This is what I want to show you. But it was copied, decompressing the iOS, which is it's compressed in Flash, and then copying it into RAM. Would you like to enter initial configuration dialog mode? If you ever see this, always say no. Okay, no one ever uses this anymore. I won't go into it here. And then sometimes it will ask you, do you want to exit something mode? You'll say yes, and always say no here. Hit enter. There's our prompt. So what are we going to do here? It's the same iOS, same configuration type of commands that we did on the switch. Okay, so let's go ahead and get started. Instead of my prompt defaulting to switch, it defaults to router. So let me type enable config T. I got to be careful here because if I make a mistake, I could get all that weird stuff. So let's actually do that. No IP domain lookup. When I said the weird stuff, remember if I fat finger, it's actually what it does is tries to connect, look for a device to connect to under that name, and tries to connect to a DNS server, and takes about 2 minutes. Whew. This keeps that from happening. All right, let's do hostname R1. There, see my prompt changed. Let's configure the console port, not line console 0. Similar type of commands. I'm going to do a logging synchronous. I'm going to do exec timeout 00. I'm going to do a password Cisco. Give me a login prompt, and there we go. Okay. Let's also configure it for telnet. Okay. So I'm going to do line VTY 0 _ 4. Can I spell 4? 4. Okay. I'm going to do password Cisco login. Okay, I'm going to do also transport input. Remember, we're going to use telnet. All right. And I think we're all good to go there. All right. What else do I want to mention real quick here? All right, we're not going to encrypt these passwords. You don't have to do that on here, but you know how to do that service password encryption. Okay, I'm going to do exit here. Now, you can't actually telnet, even though we've set this up here, line VTY and all that. It actually won't let you telnet unless you've configured an enable password. Okay, that's a little security. So somebody doesn't, if you never did a password to go from user mode to privilege mode, it says, no, I'm not going to allow people to remotely access in and then change the privilege password and maybe lock legitimate people out or something. I don't know. Anyways, let's do that. Okay, so we're good to go there. Now I'm going to do exit. So these are all the commands that we did on the switch. Okay. I'm going to do one of Rick's favorite commands on a router, show IP interface brief. This will show you your interfaces. We're going to be configuring these. Is there an IP address assigned? No, there isn't. Administratively down means it's in shutdown mode. Okay, that's why we have these red link lights here. It's administratively shut down. Okay, so what we're going to do is configure IP addresses for both IPv4 and IPv6 on both interfaces. So let's get started. This is fun stuff. Okay, so I'm going to go global configuration mode. The first interface I want to configure is this one here, Gigabit Ethernet 0/0. This one right here. So I'm going to say interface, and I can just do enter or interface. And I can say G, or I can just type out the whole thing. I'll type out the whole thing for right now so you can see it, or autocomplete. And which one? We have 3 ports, 0, 0, 0, 1, 0, 2. We're going to do 0, 0, because that's the one that the switch is connected to. Okay, notice my prompt has changed. The first thing I'm going to configure is an IPv4 address. And I could just do a IP add or address 192.168.1.1. That's going to be the default gateway that our PCs on that LAN are going to use, like PC1 there. And there's our subnet mask. Now, because we all love IPv6, at least one of us does maybe, is I'm going to do IPv6 command. And the difference here is you say v6. Now, our IPv6, oh, did I not put it there? I will put it up here. Oh, I didn't add the IPv6 addresses. I will add it so you'll see the IPv6. You don't see it on the video here. Oh, bad Rick. All right. Let's do 2001 DB8 cafe. We all like go to the cafe. So we're assuming this might be what our the /48 that our ISP gave us. We'll make this subnet 1, and the host will be the interface ID, all zeros and a 1. And the prefix length, no space, /64. That's the global unicast address. Now it's now given itself automatically a link local address, but we want to make that easy to remember. And it's also going to be what's going to be used as the default gateway for our devices. So I'm going to give it another address, FE80:1. Remember that link local address, but we actually have to say link local. You got to say link local after it. Okay, and that'll be what the other devices will use as their default gateway when using IPv6. All right, we're pretty much done except for one thing. You see this red link light? Still in shutdown mode. Let's do no shutdown. Press enter. Notice this turns green. On the switch, if we were looking at the actual switch port, it would be amber. It's running spanning tree, okay? And it's going to take upwards of 50 seconds to start forwarding, turn green and start forwarding. We'll talk about this later. Oh, so much good stuff. We're going to talk a little bit about spanning tree and how to have some of our ports automatically go into forwarding state. Okay, we'll talk about that later. Oh, there it goes. It turned green. Okay, so that was my gig 00. Let me go ahead and now do exit. And I'm going to do gigabit 01, the other one. Okay. Now I could cheat here. If I want to do up arrow, look how nice this is. See, it took me all the way back up to that prompt, hit backspace 1. All right. Just to show you, I could also just do interface G0-1, same thing. Now I'm in interface gigabit 01. Let me give it an IPv4 address. It's on a different IP subnet, 192.168.2.1. And the router interfaces must belong to different subnets or networks. You can't configure the same IP address. I'm sorry, you can't configure the same physical interface to belong to have different IP addresses on different subnets or networks. Let me say it again. You can't have different physical interfaces with IP addresses belonging to the same network. There we go. That's what I wanted to say. Okay, so we couldn't configure this to have an IP address that belonged to this network. All right, we give it the mask. Okay, let's give it an IPv6 address, 2001 DB8 cafe. There's how our ISP sees us. Let's make that subnet 2. So easy in IPv6. And we'll make it the host portion, the interface ID, all zeros and a 1 /64/64. Remember, that means that this is the prefix. And this is the host portion or interface portion. Okay, I'm also going to say IPv6 address, FE80:1. Link local address can be the same address as long as it's on different links. It only has to be unique on the link. I'm going to show you that we can do that right here. We'll see how we use that in a moment. Okay, again, I'm going to do no shutdown. All right. Notice green link light here, amber here, a spanning tree gets going. All right, we're almost done here. I'm going to do end to take us back to the root prompt. Notice that after I did the no shutdown that we did get messages from iOS telling us that those interfaces are now up. Now, in fact, we'll take a look at that. I'm going to do end, show IP interface brief. And notice here's my 2 interfaces with the IP addresses. And notice that they show that they're up. I can do the same thing for IPv6. Let me just hit the up arrow. I just change IP to v6. Slightly different format, but here's my interface. It's up and up. Here's my link local address, and here's my global unicast address. Link local, global unicast. Global unicast has to be different, but not the link local. All right. One more thing I need to configure on this router for IPv6. This command here, IPv6 unicast routing, done in global configuration mode. This is actually, I can configure the interfaces for IPv6, but it's not routing for IPv6 until I give that command right there, IPv6 unicast routing. I'm pretty happy with this. So I'm going to do exit, copy running config to startup config. Okay. And as a student, I probably want to also save my packet tracer file. Okay, now we can just do some more cool things. We're going to configure, we're done with the iOS. Okay, now we're going to configure the PCs. So let's go ahead and do that. PC 0. Let me move that over here. I think I can actually get rid of that. Okay, PC 0. On PC 0, I'm going to statically configure its IPv4 and IPv6 addresses. So I'm going to go over here to the config tab. I'm going to click on fast Ethernet right here. See this guy? Click on that. There we go. And I'm going to statically configure an IPv4 address, 192.168.1.100. Click on the subnet mask so it gets a subnet mask. Then notice it already gave itself a link local address, an IPv6. Yeah. Good packet tracer. All right. Now I'm going to give it a static IPv6 address on that IPv6 network. 2001 DB8 cafe 1 : okay, so that's the network portion, : 100. Okay, there shall be and then here's the prefix length 64. All right, looks good. Settings, let's do a default gateway. The default gateway will be 192.168.1.1. for IPv4, for IPv6, it's all static here, FE80:1. Okay, that's this link local address, but notice the router has two link local addresses. Link local address, the only link local address that PC0 or PC1 can access on this network that's FE80:1 is this one here on this router. Link local addresses, stay on the link. You can't reach link local addresses on other networks. All right, let's close that. Next, let's go to PC1. Now, PC1, I'm going to do something slightly different. Okay, so PC1, we're going to do static for IP. Click on Fast Ethernet 0. There we go. Got to do that. Static for IPv4. Okay. Now, if we had a DHCP server or a router was acting as a DHCP server, which it can, we could actually do DHCP for IPv4. And those devices would, these client devices would get their addresses automatically. All right, but let's just do this 192.168.1.101. Now I'm going to configure this to automatic. Look at this. We'll verify this in a moment, but it got an IPv6 address automatically. That's from the router advertisement message that Rick talked about in class. Okay, that when we did that IPv6 unicast routing, this router sent out a router advertisement message saying, hey, this is the network you belong to, 2001 DB8 Cafe 1. Create your own interface ID, which this device did. Okay. Now let's go over here to settings under global. We're going to configure a static default gateway, 192.168.1.1. Okay. But look at the IPv4. When we did automatic for the interface, it does it also for the gateway. FE80:1. How did it get that? Again, from the router advertisement. The router advertisement was sent from the source IPv6 address FE80:1 on this interface. So this device says, great, you're my local post office. You're my way out of here. So I'll use your address as my default gateway address. Pretty darn cool. Okay, that's PC1. Okay. We can verify these addresses, by the way. So what am I? Let's go to PC0 here. And we verify these here. Desktop, command prompt. So desktop, command prompt. We can do ipconfig. Okay. And here's our IPv6 link local address. We did this statically. This one here was dynamically. But statically, we configured an IPv6 address. Statically, we configured the IPv4 address, subnet mask, default gateway for IPv6, and default gateway for IPv4. That was all done statically or manually. On PC1, let's verify its information. Desktop, command prompt, ipconfig. Move that out a little bit more. There we go. So it created its own IPv6 link local address. It got this from the router advertisement message. It got the prefix. It created its own interface ID. And it also got the default gateway address from the router advertisement. Okay, we statically configured this, and we statically configured the default gateway. Okay, last but not least, let me go ahead and just do server 0. In case we deal with servers in this class, it's about to have some, we did in my CSE ADN class, we dealt with this a little bit, but let me just go ahead to config. We're going to statically configure, let's do the fast Ethernet interface first, and it is 192, if I can spell that, 168.2.8 subnet mask. Let's give it IPv6 address, 2001 DB8 Cafe 2 8. Notice I keep these the same, the host 8 and 8. I think that was 64. Okay, let's go to settings. Let's configure the default gateway, 192.168.2.1. Talking this side now. And default gateway, FE80:1, link local address, but not this one, this one. Okay, it's the only one it can reach. That's FE80:1. All right. Okay, we're all set. Okay, and almost done, believe it or not. Okay, now what about this switch, Rick? You never configured it. For a switch to do what's its basic switch operations, which is forwarding Ethernet frames, builds a MAC address table, forwards Ethernet frames, and hopefully running spanning tree, no configuration needed. Comes out like that right out of the box. Okay, but if we don't want to manage it or anything, we can leave it alone. And we're going to do that in this case. There's no sense in having to configure a second switch. But let's verify a little reachability. Then go back to PC 0. Let's see what we can reach out there. I'm going to go to command prompt. Okay, let me see. Can I ping PC 1? Let's try. What ping? 192.168.1.101. Can I ping it via IPv4? Yes. Okay. Can I ping my default gateway? Ping 192.168.1.1.1. Yes, that's looking good. Okay. Can I ping server 0? IPv4. Let's try it. Ping 192.168.2.8. Rick's holding his breath. What's happening? What's happening? Timed out. Oh, why did it time out? ARP request. Either the ARP request for the default, well, not for the default gateway because we pinged it, probably the ARP request between router 0 and server 0. Okay, so it's not unusual to see the first ping or two timeout. Okay, let's now verify IPv6 reachability. Okay, now PC1, it has that IPv6 address, that long IPv6 address. All right, and actually, I'm just going to copy that in because I know what it is. I think I've got this right. Okay, this was the IPv6 address. If I do IP config of PC1, that's its IPv6 address. Okay, and it can reach it. Okay. As far as pinging its link local address, we could if we wanted to, but we don't need to do that. But let's ping the link local address of router 0, our default gateway. Remember, that's our default gateway. I do IP config. Let's ping our default gateway. I could ping its global unicast address as well. Okay, FE80:1. Okay, so yes, I can ping the router's link local address. I can also ping its global unicast address. That's its global unicast address. That's the router. Okay, but can I ping our server? Let's try. So our server, cheat here a little bit, is 2. That's the subnet it's on, :8. Look at this. We've got complete reachability. Now, one more thing I want to do is we configured an IP address on the switch. What does that allow me to do? Okay, we also can do the same thing on the router because it has an IP address. But let me show you. I could telnet to the switch. Remember, we gave it the address 192.168.1.5. There's my banner message of the day. Okay, Cisco is the VTY password. There we go. I can even do enable class. Look at that. I can remotely access the switch. Just don't make any changes that remove your access to the switch, like changing the IP address or something called an access control list or something like that. Okay, but I could do all kinds of stuff here. Okay, show whatever, you know, just like I was on the switch. Exit. Okay, I exit out of that telnet session. I could also telnet to the router, 192.168.1.1. Okay, I didn't do a banner message of the day, did I? Oh, typed in the wrong password. Oh, see if it takes it. There we go. Enable. So now I'm remotely accessing the router from my office on PC0. All right, I think that's long enough for a video. I hope you enjoy this. Remember, you have all this cool stuff here, okay, in the Word document. Use it as a reference. Create your own reference. Oh, one last thing I need to show you. Sorry, always one last thing. Okay, don't forget to save these configs. And something I need to show you. Okay, so we copied the running config to startup config. Okay, I'm on the router. Show running config. Okay, in Packet Tracer, what I do is this. Copy, well, first select. I'm selecting all this. You got to use this copy right here, copy. Then I can open up a Word document or text document or whatever. And then I can just do paste. Okay. And you can save your configuration session, everything you've done here. You can save all of this good stuff to a document if you want. But when I ask for a running config or any information, this is how you copy from Packet Tracer to some kind of text document, Word, PDF, TXT, whatever you want to use. Okay. Usually use Word or TXT. All right. All right, I think we're good. Don't forget to have saved your copy running configs to startup configs. And when you're all done, save. Okay. All right. Thank you for watching this video. I hope you enjoy this. Have fun with this. You can't break anything in Packet Tracer. You're not going to hurt anything. All right. That's the joy of this. Hope it's all fun. All right. Have a great rest of your day or evening.